So my name is Hendryx-Parker. I am CTO and co-founder of 6 Feet Up. I want to thank you all for coming out to our first Cloud Conf here in Indianapolis. I think it was a success, although I think there must have been so much content that some of the people just couldn't take it anymore and they had to go home because I think we've had a dramatic drop in the number of people in the room. But that's all right, because these are all being recorded. We will have the talks up online along with all the slides linked to from the cloudconf.com site. So if you just go to that site, it'll show you all the past talks, plus it should give you video after we process the terabytes of video we have recorded today. But I do want to kick off the end of this show before we get to our social with where the wild cloud things are. Does anyone know what story I'm referring to here? Who as a child had read this story? Okay, I actually didn't, funny enough. I became familiar with the story as more of an adult because we would go to costume parties and some people would dress up as Max, put on the wolf costume, and I was like, what is that? And then they'd show me the story, and then I started reading it and got into it. And it's actually a really, really cute story. We don't even own the book. I never even read it to my own kids. I feel like a bad dad, but we did read them a lot of other stuff. But I do have my own story time. And before, did Angel check out of here already? I loved Angel's description of himself as a developer with operational tendencies, because I definitely classified myself in that same space, which I think makes us well suited to this kind of new DevOps world, because it really is that understanding, or I like hanging out with operational type folks, but I'm definitely a developer at heart. And so it makes us really well suited to this kind of thing. So the story I want to tell you, though, is a story you may have known or been told as a child, or as a maintainer of cloud infrastructure. My story won't be about Max, but it's going to be about Dan and his data center. So we'll talk about Dan here. So the day Dan wore his sysadmin suit, he made mischief of one kind and another. His boss called him Wild Thing, and Dan said, "I hate the cloud." So he was sent to the data center without eating anything. And that very night, his enterprise grew a cloud. And it grew and it grew until there were regions all around the globe delivering his applications. Dan came to a place where the wild cloud things are. He met with the bus factor, volatility, precariousness, and wastefulness in the cloud. The bus factor roared its terrible roar until Dan said, "Be still." And it tamed it with his magic tricks. You want to lower that bus factor to lower than a factor of 1, because everyone knows if that one guy goes on vacation, everything comes to a screeching halt. So in your organization, do you have that guy, the one guy who seems to have that certain knowledge in his head? Is he that wild thing? And there are multiple cases where this guy, he was let go or walked out the door. I mean, for example, we've worked with an organization where they recently let a fellow walk out the door, or I can't remember what the circumstances were, but then at this point in time, they had no idea how the release process for their software worked. We asked many questions, we couldn't find any answers. So how do we actually deliver the ability for us to lower our bus factor lower than 1? Miss Angel, I mentioned you in my very much intro here about the operational tendencies. I definitely related to when you said that. So how do you defeat the bus factor? How do we, as Dan in the place where the wild cloud things are, defeat the bus factor? So we'll go over a few different ways you can defeat the bus factor. The first one is going to be to simplify. It's probably one of the hardest, maybe the most rewarding, but it's basically to leverage more cloud native tools. We want to take and refactor aggressively, if possible, to get to a simpler version of ourselves so there aren't those complexities that one person has to stuff into their head. And we want to refactor our applications into microservices where possible, or the opposite when it actually makes more sense. Microservices aren't always the end-all, be-all answer, and the monolith may actually be a simpler solution to our answers. What comes down to is what makes sense for the team and actually how you can reduce that bus factor to lower than 1. And putting in place repeatable systems. This is actually a theme that's been repeated over and over again throughout all the talks today, I think. It's been a really, really common theme, which made me feel good about having it in my talk, because I must be right on the right track. And we want to build that, or fix the build process to be fully automated, so you truly get that push button aspect of being able to repeat things. One of our how do you go from the closet to the cloud? You can do things like a lift and shift, and I think some people mentioned that earlier today, and they're exactly right. There's issues with just a straight up lift and shift. You haven't reduced your complexity, you haven't actually reduced any of your susceptibility to fault tolerance. You've actually just taken your existing costs that were sitting here and moved them to another spot. It's inefficient and it can be expensive. So if we talk about taking a lift and shift and moving it into an AWS cloud native architecture, this is absolutely possible and easy, and may not be easy to do, but it's definitely worth looking into so you can leverage those tools and components that make up the cloud. For example, we took Notre Dame's College of Engineering, literally had the server living in a closet someplace. The connectivity must have been an Ethernet cable that the secretary walked over daily and kicked because they would go down throughout the day for no good reason. Moving that monolithic server up into the cloud would have just moved the problem up into the cloud, but not actually allowed them to leverage services that give them better high availability. So taking and replacing the database server that was on their existing bare metal hardware with hosted solutions for the various clouds, like an RDS type solution. Replacing the HA proxy and varnish pieces with elastic load balancers and CloudFront service now reduce the amount of configuration that was actually needed to bring up any new instance of this application to host the site. Taking and sharing files, for example, for all the blob storage, moving it from being hosted on NFS, now doing it over EFS, meant there was no more NFS dedicated service to manage on our own. We actually just left it up to the cloud services to do that for us. And then putting the backups into S3 to get the, 13 nines of durability is a much better option than anything they could probably even have done in their own data centers on their own campus. And lastly, you could take and build images to make the release process go as smooth as possible and reduce any kind of downtime. So being able to take and actually build these golden images that can be tested and then released immediately into production without any change allows them to cycle out old images of the old software, cycle in new images of the new software, and enable them for almost a zero downtime release of software in a much faster way they could do it. So all this adding of these extra bits that are cloud native pieces actually simplify their operation because they aren't touching and managing and maintaining all those pieces that were on their own server. They've delegated that work, offloaded that piece of work into the various cloud provider, in this case, AWS. The next way we can beat that bust factor is to document. Who loves doing documentation? I got a couple half raised hands. I think this is incredibly important because as we want to make sure that the rest of the team is well aware of all the things that are going on inside of the organization, you want to be able to make sure you create the docs, curate your docs, update your docs, and importantly, culling old documentation. There's probably nothing worse than wrong documentation than no documentation. I don't know if anyone has ever run into wrong documentation. I will talk about this later in another section, but wrong docs will lead you to waste uncounted numbers of hours. But part of the culture of your organization itself, and a lot of these talks have actually been about culture, which kind of made me happy as well, was that it should the documentation should document how it should work and not how it is broken. So for example, if you're reporting issues into your issue tracker, saying something is broken doesn't necessarily say how it was supposed to work or what the intention of that feature or fix should be in the actual software. So if you actually document how something should work, it means that later on down the line, because you may be maintaining the software for numerous years, 10 plus years, looking back upon how that feature was built, you'll have more context and more understanding when something goes wrong or when there's a question about why a certain decision was made versus this thing is broken and there's happened to be some fix made for it. Was it the right fix? We aren't sure because we didn't document it correctly. So repeating and repeating, so repeated usage of this documentation also allows us to ensure traceability. It's the only way that, for example, that our company, 6 Feet Up, can support customers we've had for over 10 years. We've had customers where the stakeholder from the client is long gone. There were 2 or 3 generations in on people who have now taken over this project internally for that organization. But traceability inside of our documentation. So for example, as code commits are created, they have the issues numbers automatically attached to them, which then attaches them to the tickets, which get attached to the user stories, which get attached to the epics. Allows us that ability to now, 10 years later, see why a certain decision was made. Because you can imagine some new stakeholder being like, well, why didn't we develop this certainly obvious feature? Well, we have a good reason why we didn't, and it's actually documented right here in our system. How many times has someone left a company and you didn't know what passwords they had either on their computer or in their head? This has certainly hit many of us. But the management of secrets and making it easy, one of the hardest parts of security is making it easy. If you implement security controls, typically it makes things a little harder or more difficult, or it affects adversely the usability of a process. But if you can actually help facilitate the management of secrets, for example, by using tools that allow you to audit, rotate, or somehow do programmatic access or retrieval of database passwords, these kinds of tools will actually allow you to ensure you have distributed access or controlled access to the various kinds of secrets. I won't actually ask anyone to raise their hand, but you probably know who you are. You've had an AWS secret somewhere written on your hard disk at some point in time in an unencrypted form. I will admit it, I have done it at some point in time, but I do not do it anymore, and I'll show you actually how I solved that problem and helped eliminate the bus factor monster. But some tools up here that we've used or are using right now, for example, is HashiCorp's Vault. One of the things I really like about Vault is it allows you to give kind of that quorum of people need to be available to actually unlock certain kinds of secrets, and it also enables the programmatic access of secrets. So if you want to have a cluster of 10 Django applications, each of them can have their own unique credentials to the database that they get on startup. And those credentials only ever exist in the database temporarily while that instance is running, or in the memory of the application while it's running. As soon as that application terminates, the database is cleaned of those credentials and they no longer exist. So if one instance becomes compromised, you no longer have compromised the whole database or all the rest of the application. You just shut down that one instance of the application, and the rest of them continue on their merry way serving everything up. The AWS Secrets Manager supports a similar type of functionality where it can generate secrets on the fly. And then for if you don't want to go through the process of setting up some of these tooling, anyone in your room use LastPass for their password management? I'm a big fan of LastPass. One of the nice things is people have written some command line tools for LastPass. So if you're not aware of this, you should definitely check it out. But there is a command line interface to LastPass that will allow you to grab, for example, the environment or populate environment variables for your AWS secrets, and then put them into your environment only during the duration of that shell. Actually, I'll show that off right here, maybe. Oh, here we go. This is a new trick I've never done. Here we go. So if you actually look at my environment, and I'm going to grep for the AWS environment variables, this shell currently has none of them available. Use the LastPass command line tool to log in as my user, so it actually shows that I'm already logged in. And there's a shell script someone wrote called lpass-env, and it will use the notes on a LastPass entry to populate environment variables for your secret, your key, and you can also do optional other ones like, for example, the region, or if you want to just populate the profile. So if you're, for example, working on, like me as a consultant, we typically work on multiple projects at once. And so I can have different profiles set up in my AWS credentials file for different customers. They may have different region settings or different settings for specific tunables to that environment. I can now store them in the notes field of LastPass. When I start working on the project, run that one command, and now those are in my environment. As soon as I exit that shell, they are now gone from my environment and no longer available to anyone who may gain access to my laptop. And one of the last ways we can defeat this bus factor monster is to help cross-train the teams. So again, another kind of a culture item where it's important to do things like, for example, pair programming, or doing code review sessions, or show and share sessions. We don't have a super formalized code review process at our organization because we're a fairly small group. But one thing we do is every Friday afternoon, we gather together in the big conference room and online, and we do a kind of a show and share of like what people are working on. Maybe they want to show off certain codes, code snippets where they've solved a certain kind of problem, or they have a question on how a certain problem is solved. So we get together and just basically do a little, as a kid, like show and tell, kind of like kindergarten at 6 Feet Up, which is nice. You get to show off cool tools, and then it actually helps others in the team, or discover new tools or discover new processes, and actually improve their way they make code. Doing professional development, where you can actually cross-train multiple employees on certain technologies you may have, helps reduce that bust factor again below 1, which is what we want. And then knowledge transfers. Do you have a formalized process in how you actually get knowledge transferred from one person to another, or even from a client to your own organization? We were working with a large organization which had a fairly high bust factor. Had a bust factor of 1, which is dangerous. Correct? You don't want that or you want those couple people having all the knowledge kind of walking off or being hit by a bus. So going through and having a formalized process for getting that knowledge brought in-house to your organization can make a big difference for that client as well, because they may want to actually offload part of this bust factor monster to you as a consultant. The next monster. So volatility gnashed its terrible teeth until Dan said, "Be still," and tamed it with its magic tricks. How do we handle inexperience and gaining knowledge in such a volatile world as the cloud is right now? The cloud services and the cloud providers, no matter who you're using right now, whether it's AWS, Azure, Google, they're ever shifting. The AWS docs are better, but there are still issues. How many people have shaken a fist at the AWS docs in this room? Yeah, there's 2 hands up from that guy there. This is one of my favorites. Is that the AWS docs are open source, so you can go fix all the problems you find if you like. Someone did take the time to at least put in a little bit of a snarky pull request here. Who's ever used CloudFront and done a deployment and been like, all right, well, I'll go get a coffee and maybe lunch and come back when maybe that's all done. The docs used to say, I think 15 minutes. And so someone put in a nice friendly pull request saying that the CloudFront regularly takes more than 20 minutes to deploy. This updates the documentation to reflect my experience. And then actually Amazon merged it. So the documentation, it is friendly. They are not an adverse group to taking in your comments, but the docs can be definitely misleading. They tend to lag behind as they're moving forward so quickly. I mean, how many services a day does Amazon release, or how many updates and feature changes are they releasing each day? To keep those docs in place definitely requires an army of people. So addressing volatility, there's lots of different areas here where we can actually increase our learning and increase our knowledge on the various pieces of the cloud. There's some simple things you can actually go out there and do that are actually free. For example, Amazon offers accreditation from a business and technical standpoint. It's pretty much watch some videos, understand what their buzzwords all mean. I recommend it to anybody who's kind of unfamiliar with that platform. It's an easy way to basically ramp up quickly on what their terms are for maybe something you're already familiar with. So you can get your accreditation. It is free. I haven't found a way to cheat by getting the videos to fast forward so I can just get to the quiz, but you'll just have to sit through it. The next step after this is going to be certifications. So if you want to go on to get the cloud certifications from any of these various vendors, I mean, it's a good learning experience. Sometimes I wonder about certifications on whether they just mean you can take a test and know how to memorize material, but I think there is some value in that, especially if you have a team that is new to these various cloud technologies. It's a quick way for them to spin up on the areas that AWS thinks are important and probably you need to use. Another area for the addressing this volatility is going to meetups. They are all around. All it requires you to do is show up. It's one of the easiest things you can do. We run the Indianapolis AWS user meetup. We get about 30 to 50 people each month on the third Tuesday. It's, again, very low effort involved here. You can even order lunch and eat it at the same time. So you can accomplish 2 things at the same time, very easy to do. But I think a lot of groups or a lot of people don't leverage these kinds of meetups. There are speakers coming from all over, at least for us, from all over the United States and all over the region to come and actually speak and share their knowledge at these various meetups. Last year we had a Gartner consultant come in and give an excellent presentation comparing all the various cloud platforms and kind of giving a perspective on what's good about this one versus that one and why one's more popular and where these other ones are going to and what's kind of the next steps in the roadmap are for them. It's really hard to get that on your own if you're just kind of sitting at home, maybe if you're a remote worker or you're in an office, and not actually socializing with others who are doing similar types of things as you are. Great place to meet other peers. There is also the Slack channels that go along with our meetups. So IndyPy has its own Slack, and Indy AWS is on the Indy Hackers Slack channel. So I highly recommend getting into those. There's lots of channels that are inside those Slacks. If you want to talk about board gaming or other kinds of random social things, those are good. But at least you start developing that attachment or a connection to the various communities who are doing these kinds of topics. The next one is going to be training. So to get the volatility monster, there are lots of online training opportunities and lots of physical in-person type training opportunities, or there's lots of opportunities for you to go in person to training boot camps. For example, Cloud Guru or Cloud Academy. They're all offering various promotions and discounts. Definitely things that people just need to take advantage of and go do. If you're more of a self-paced learner, kind of like me, I really enjoy blogs and podcasts. These are a couple AWS-specific podcasts. One of them is actually from Amazon. The other one is Corey Quinn, the Screaming in the Cloud. If you appreciate the more snarky style of a podcast, you'll definitely want to check out the second podcast on that list. And then YouTube is full of like people who are, we actually record all these sessions and have put them online. All the Indy AWS sessions are online. The V Brown Bag group, they kind of spawned from a VMware group, which I'm not a VMware person, but I happen to know some friends who are. They've started a series of how you do DevOps in Python. And so they invited us in to come and speak. So actually one of the last talks down there on that page is actually one I gave about using the Boto3 Python library to interact with the AWS APIs. It's a lot simpler than you would think, and it's actually nice to be able to watch people step through presentations online, be able to ask questions in the comments. A lot of these are live streams, so you can actually ask questions in real time if you're kind of following them. So I'd recommend going and subscribing to, for example, the V Brown Bag channel, because there's tons of information and resources out there. The next monster up is precariousness. Precariousness rolled his terrible eyes until Dan said, "Be still," and tamed it with his magic tricks. This is all about reliability. How do you know when something's going to go wrong? How can you predict? How can you forecast? How do you know what the past even looked like? How do you know where your vulnerabilities actually lie as far as reliability and availability of your application? Again, I'll kind of point back at Angel's talk earlier about the MongoDB issue. 3 months in, all of a sudden, IO's thrashing. If Nagios is the tool you got and you leveraged it, you were successful in your mission, even though it was Nagios. There's lots more awesome tools that are out there right now, though. One I'm recommending to folks is Prometheus and Grafana. This is actually a Grafana dashboard of my laptop. So it has a Prometheus agent running on there. Like he had mentioned, they're just super lightweight little agents. They just respond to REST calls, like just HTTP calls, super fast. And then they all kind of centralize, pull their data all back. There's commercial options that are similar, like Datadog, for example, is another good option where it's basically going to suck in as much data and as much information you can about your systems, so you can now make educated decisions about where you're going to go as far as scaling. Maybe you're not using enough, maybe using too much, maybe you've got bottlenecks in certain areas you weren't expecting, maybe the IO is thrashing and you didn't know it. So from a system level, you can gain tons and tons of insight. This is my favorites. My laptop has 8 CPU cores. This is so rad. Then once you've gotten insights into the actual infrastructure, the next step is actually instrumenting the application layers. There are tons of Prometheus exporters. So Prometheus itself has a node exporter which gives you, this kind of data about your system. But if you actually want to start implementing and integrating in information about your various applications, so for example, HA proxy, Varnish, the database servers, you want to log slow queries, basically track all these various pieces of data about your infrastructure, is when you want to pull out and actually start doing some instrumentation in your application as well. So you've got your node exporter giving you data about the platform you're sitting on. These exporters here giving you information about the various applications that may be in your proxy chain, and the various layers of your application, such as a database. And then you can take it the next step further, which is actually in your software applications, writing your own exporters, your own kind of beacons to send off information about your application. So for example, here, this application is sending in information about logins, signups, signouts, so we can actually kind of track maybe when all of a sudden we get a spike in people logging in, we see a spike in some kind of I/O that we weren't expecting because there's maybe some errant call to a database that was overly expensive that didn't need to be there. So it can actually help you eliminate performance problems before they become a real big problem, because you can actually catch them as you see these things trending over time. And so speaking of trending over time, now that you have that data all available to you, you can put in place proactive alerts. So you can now set thresholds. If you didn't know historically what normal looked like, we can now understand it since we have the data to make those kinds of decisions. So allowing us now to alert during office hours instead of after hours when it goes down, it makes so much more sense and is much more comfortable to your system administrators who are kind of responsible for the after hours portion of this. And then if we take that proactive maintenance and automation of system provisioning and put that into a push button activity, it allows us to now spin up, spin down, scale up, scale out without having to do too much thought. How many people have had servers where that single server is the only place you can get that one piece of software to run? I've seen that. Man, Angel and I we're like brothers separated at birth. We have been around the block. I have seen it where they could not get this application to run any place else. The only way they could move it was to be imaging that server, move it someplace else, and actually just start up that image. Because rebuilding the server every time it was attempted was a failure. And that's because there's too many of us in the process, too many humans dabbling on the server. If I had it my way, and if you've ever seen my rules of DevOps talk, the first rule of DevOps Club is no one logs into the server. It's also the second rule of DevOps Club. Now the monster is wastefulness. So wastefulness showed its terrible claws until Dan said, "Be still," and tamed it with his magic tricks. So when we're in the wild cloud, where the wild cloud are, we need to talk about how we can do things. For example, if we're looking at wastefulness, it happens in multiple areas, correct? But it all kind of comes down to dollars, right? Monitoring how much you're spending. Are you overspending? Are you underutilizing resources? And that proactive monitoring from the previous step is actually going to lend itself to being able to detect whether we've got wasted resources, whether we're only using, say, 90% or only using 10% of the actual platform when we could be leveraging that other 90% to do more work for us without spending any more dollars. So Amazon provides the AWS Cost Explorer. If you've not had a chance to look at it, I highly recommend going in there. You would be surprised at where money flows inside the AWS system. They're very good at getting you to sign up and click buttons and use APIs to spin up services. They don't ever try to tell you to turn them down necessarily, unless you pay them more money. Then they'll actually will tell you to turn them down. But you can come in and see your costs and slice and dice based on all kinds of various factors. Probably one of the more interesting ones is if you actually go through and look at the split out by service. And what is interesting here is actually the one that says EC2 Other. You'll notice money going there, and you may not be sure what it is. But if you actually go read the documentation, that has a lot to do with between availability zone transfer, and most of it's like data transfer. Amazon makes a lot of money on data transfer. And if you can eliminate that data transfer fees, for example, you can greatly reduce your bill and expand maybe the capacity in other areas with the same amount of budget. Then you can split it up, cost by service by month. This is a pretty simple example. And leverage their tools. So they have a recommendations section of the Cost Explorer where it will actually tell you should buy X number of whatever resource reserved instances. And then they can actually tell you the associated usage, like where you're using those things to determine whether that's something that was just transient and you were only using it for this month, or whether that's something you've got running more on an ongoing basis. What is interesting about reserved instances, I don't think a lot of people realize, is that, for example, it says by 20 T3 nanos. I don't think we have 20 T3 nanos actually running anywhere in our infrastructure. What we do have, though, is like T3 mediums or T3 larges, and those can be combined. Like 2 nanos can equal a small, and 2 smalls can equal a medium, and 2 mediums equal a large. Well, having a large number of the nano reserved instances gives you flexibility with launching any variety of those, micro, small, nano, large. They don't care. They just combine them together, and whenever they apply, and you have the right kind of magic all going at the same time, you get the discount. Well, you get the lower rate that you purchased on your reserved instances. I should probably go do something. I could save $394 a year. That buys me a couple kegs of beer. I always put my savings in terms of beer. If I'd be like, oh, I saved so much money, great, we can buy a keg of beer for the office. I'm the only person that does that? Okay, maybe not. There are other excellent tools out there to help you manage cost and also compliance. If you guys have not checked out the Cloud Custodian tool, it was originally written, it's open source, originally written by Capital One. We helped work on the project to do documentation, test coverage, new enhancements, new features. But Cloud Custodian is similar to the Chaos Monkey from Netflix. Have you guys heard of the Chaos Monkey? In a way, it will listen to all the events that are happening inside of your cloud infrastructure. So for example, new S3 keys being written, or EC2 instances starting and stopping, EBS stores like block storage being attached or detached. It will listen for those kinds of events and then help you react. So a lot of times you may spin up an instance, attach some EBS, shut it down, but then forget that you had that EBS block store you spun up that you attached. Months go by, you don't think about it, and you look at the bill one day, and all of a sudden you realize, what, I'm spending money on an EBS store that's not even mounted to anything and really doesn't even matter. So Cloud Custodian can actually give you the ability to write policies that run as Lambdas. Optionally, they can run on a schedule. So for example, if you wanted to inventory S3 buckets, once a day or once a week to gather what your usage patterns are for S3. So you can run it in those 2 different modes, but Lambda is probably the most common and easiest way to run it because it's pretty much fire and forget. You write a policy, and I'll show you what an example policy looks like. It is just YAML. It has a mode. In this case, this one's run periodically. This one's not in response to any specific events inside the cloud infrastructure. It's going to run once an hour, and it's going to look for EC2 instances that have a specific tag or that will match a specific filter. So if you're looking for off hours, this one will turn off an EC2 instance that's tagged for an off hour at 4 o'clock. So the action here is stop. So the resource is EC2, the actions are stops. The resources and actions have specific tying together so they make sense. If we want to look at one that's more event-based, this one actually will clean up EBS volumes. So Cloud Custodian gives that ability to do multi-step workflows. You may want to sweep through, or actually as things happen, mark for a future operation. In this case, we can actually look at any unattached EBS volumes. We can mark them for delete after 30 days. So then they get a special, these uses the AWS tags in this case. It will mark that thing for deletion. And then if the EBS volume gets reattached to a volume sometime in that 30 days, this will fire looking for a recently attached EBS volume and unmark it. Now on the other side of that, if it never got reattached after 30 days and this is running, it will then delete that attachment or that block storage for you automatically. So you can basically garbage collect unused block storage devices without having to think about it. Now, as one person said, you can to mess up, to make a mistake is human. To really mess it all up requires DevOps. You could definitely do a lot of damage here, but the same thing holds true for a lot of other tools like Terraform and SaltStack. So Cloud Custodian does work. See the question up here about Cloud Custodian working with other platforms. I believe it just supports 3 platforms, primarily AWS, then Azure, and Google Compute. So by staring into their yellow eyes without blinking once, Dan frightened the wild cloud things who called him the most wild of all, and made him king of all the wild cloud things. And now Dan cried, "Let the wild rompus start." Any questions? I want to thank you all for coming. If there's no questions about that, I will definitely be excited to hang out, and if anybody has questions or do want to chat,